at the thermodynamic processes, okay? Now, processes is talking about those changes that takes place during a particular activity in a thermodynamic system, okay? So the first process you have to know is the isobaric process. Now, the isobaric process is that thermodynamic changes or activities that takes place at a constant pressure. That is, the pressure is constant or equal to 0. That's what it means by what? The isobaric process. Okay? So the next type of process you have to know about is what we call the isochoric process. For the isochoric process, the volume is kept constant. Now, volume being kept constant means that delta V is what? Is 0. Okay? The third one is the isothermal process. For the isothermal process, the temperature is kept constant. There are other processes, but this study is limited to this. We're going to talk about those. Okay, we can quickly talk about adiabatic process. Okay, that's one I forgot to write. Adiabatic process. Now, for adiabatic process, the Q or the heat energy is taken to what? 0 or constant. So these processes are used in thermodynamic activities to achieve a goal. Okay, so the next talk about is the thermodynamic function. Now, the thermodynamic function is of two types. We have the state function and the path function. This state function, the state function is a thermodynamic function that describes the initial and the final state of that system. Okay, that is, it tells us what happens in the initial and the final state. Examples include we have temperature, we have pressure. There are so many of them. Okay, there are so many of them. We have entropy, we have enthalpy. There's many. If you go and check in the material you will in the app, you will see those examples. There are so many variables that are state functions. So they depend on the initial and final state. So those kind of variables are variables that you can integrate through a certain limit, okay, to get the initial and the final state. So take note. Now, but the path functions are those thermodynamic activities or those thermodynamic parameters that describes the path taken, not the state, not the initial and the final state. This one describes the path taken by that word, by that parameter. Okay, so these ones, they are not much. Okay, examples of path functions include work, heat, energy. These two are key examples of a path function. Work, the symbol is W. Heat, the symbol is what? Q. So please take note. Enthalpy is not a path function. Enthalpy, which is heat of reaction, and the symbol is H. It is a state function. This one is a state function. But heat, energy, that is Q. Q is a path function. So this one describes the path taken by that system.